Today's lesson, section 9.6b, we're still talking about equations of lines and planes. So last section, or last video, we talked about the equations for lines. Here we're going to more focus on the equations for a plane. So for a plane, in three-dimensional space, it's going to be determined by the normal vector between two vectors. So r sub o and r minus r sub o at point P sub o. Okay? So this is the hinging point right here, is this point. So we still need that initial point, and then we also need this vector n. Now the reason why we want vector n is because you're talking about two different vectors. You need to create a plane, so you need to know the two vectors that are in the plane. So the nice thing with the normal vector, or the orthogonal vector, or the perpendicular vector, is that it's a combination of those two vectors in one vector, basically, because they're both perpendicular to n. And so remember how we find something perpendicular is it's going to be kind of the cross product for our stuff. So this kind of works the same thing as a plane. It's not going to be just, now this one kind of works out better as it's actually one equation, but you have three different values working together in the same sense. Okay, so for equation of a plane containing a point P and then having the normal vector n, we can describe the equation as a times x minus x sub o plus b times y minus y sub o plus c times z minus z sub o. And that's going to equal 0. So using our initial point and our normal vector, we can actually find this equation, and it'll be one equation for the plane. Okay. So let's do an example with this. So a plane has a normal vector, so let's say 4, negative 6, 3, and an initial point, or a point that it passes through, is 3, negative 1, negative 2. So if we want to find the equation of the plane, first I just need to plug the stuff in. So to my formula, a is 4 times x minus what my x sub o is, so 3 in this case, so minus 6 in this case for b, times y minus, looks like a negative 1, so I could say plus, and then plus 3 times z minus a negative 2 equals 0. Okay? Now, they kind of want you to simplify this a little bit by multiplying through. So we're going to multiply the 4's through, and the negative 6, and the 3. Okay, so 4x minus 12 minus 6y plus negative 6, and then plus 3z, that'll be plus 2, so plus 6 equals 0. So then I'm going to move the other values over. So I'm going to add 12, and then I'm going to add 6, and I'm going to subtract 6. Okay, and so that leaves me with 4x minus 6y plus 3z, and that's going to equal 12, it looks like, because those 6's cancel each other out. So this would be the equation for this plane. Okay. Now for letter B, I want to be able to find the intercepts and then sketch that graph. Okay. So for letter B, to find an X intercept, just like it sounds, it has to pass through the x-axis, so that means that y and z are going to be 0, kind of like on a 2D plane. Okay, so with this equation, I do 4x minus 6 times 0 plus 3 times 0 equals 12, and so those go away, so you're left with 4x equals 12, so I need to divide by 4, so that means x equals 3, so my x-intercept is 3, 0, 0. Okay. Y-intercept, that means that x and z are 0 this time. So 4 times 0 minus 6x, or 6y, plus 3 times 0 equals 12. So that makes those go away. I divide by -6. So y is equal to -2. So my y-intercept would be 0, comma, -2, comma, 0. Now for my z-intercept, x and y are 0 this time. So I plug those in, and I get this solved for z. So those go away. Divide by 3. That gives me z equals 4. So be 0, comma, 0, comma, 4. So the other thing they say is they want you to sketch the graph. Okay, so let's do that. So if I make my plane here, now this one might be a little harder to see because of the way the plane is oriented, but I'm going to do my best. So x has an intercept of 3, 0, so that would be right about there. Okay. Y was -2, so 0, -2, 0. And then z was 4, so it's right up here. Okay, so for this one, so then my picture of my plane will kind of look like this. So it's kind of slanted. It's like a triangle, just facing this way. Okay, but that would be the picture that I would draw for letter B. Okay. Example 5 wants us to be able to find the equation of the plane, but they only give us 3 points. Okay, so we need to find 2 vectors that make up this plane. Therefore, we also need to make or find the normal vector, so the perpendicular one, and then plug in one of our points from the plane, and then find our equation. So let's do P, Q, and P, R. So for PQ, -2 minus 1, 5 minus 4, and -1 minus 6. That gives me -3, 1, -7. And then for PR, you have 1 minus 1, -1 minus 4, and 1 minus 6. So here, that gives me 0, -5, comma, -5. Okay, so my 2 vectors. Now remember that for 2 vectors, if you want the normal vector, that's the cross product, because the cross product of 2 vectors is perpendicular to them. Okay, so doing the cross product there, so then -3, 1, -7, 0, -5, -5. Remember for this one, how we have it, we need to pick the top. So the first one's positive, and then I cross out the column and row that it's in. So 1 times -5 minus -5 times -7 I, and then minus, because j is in the negative position, I get -3 times -5 minus 0 times -7, parentheses, and then plus, I get 0 times 1 minus -3 times -5, k. So then now, -5 minus 35, I, and then minus 15 minus 0, oh, and I forgot my j, and then plus 0 minus 15k. So then -40I and it looks like minus 15j, and then minus 15. Okay? Oh, looks like I got those in backwards order. Let me reverse this, okay? So I should have had negative 3 minus, or times negative 5 minus 0 times 1. That's my fault. So then these two should be switched around as well. So then it should be positive 15k. That's my fault. Okay, so there's our vector. Okay, so now, using our normal vector and a point, it looks like we used kind of P as that pivotal point. So let's use P as well. So then, negative 40 is my A times x minus 1 from that point P, minus 15 times y minus 4, and then plus 15 times z minus 6 equals 0. So then do the same thing, distribute. So then negative 40x plus 40 minus 15y plus 60 plus 15z minus 90. So here if I subtract 40, subtract 60, and add 90, and simplify my equation, I get the negative 40x minus 15y plus 15z is going to be equal to negative 10. Now here I could do a little bit more simplification. They all have a common factor of 5 in between them, so I could divide everything by 5. So that makes me negative 8x minus 3y plus 3z equals negative 2. So that would be my equation. Okay? Have fun.